Okay, this is my second video here. Properties of summation. We're gonna do summation properties. Oh, but Judah is here to say hello. Say hi, Judah.
Hi.
You gonna draw something?
Yes.
He just wants to draw something for you all. No. What are you gonna draw? You gotta be in here in this part of the picture. Are you watching Peppa Piggy? Draw right here on the paper. I don't know what this is. Oh, it's kind of crazy looking. Oh, okay. What is it? What is it? 5 plus 5 equals 10. Excellent. Thank you, Judah.
That is our mini golf course.
This is our mini golf course. All right. I appreciate it. See ya.
What?
I thought you'd get a kick out of watching him. All right. So these are the summation properties. Here's the first one. So if we're taking the sum of a constant from k equals 1 to n, all you have to do is take that constant and multiply by n. So just let me give you an example here on the side. If you had the sum of k equals 1 to n of just the number 5, okay? So what you would write out would be 5n. That's it, 5n. Easy breezy. Easy breezy, okay? Here's another summation property. So this is the sum from k equals 1 to n of c times a sub k. So that means some function related to k. You can actually take that constant outside of the sum and then multiply it later. So if I had the sum of, from 1 to n, let's say of 6k squared, okay? You could take that 6 outside of the sum and then figure out what this is, which we're going to learn in a moment, and then multiply 6 inside of it, okay? Then the third summation property is just adding and subtracting of sums. So if you have almost like a polynomial inside of here, you can take the sum of each one separately. So if I had the sum of k squared plus 5, then you could actually separate it into the sum of k squared plus the sum from 1 to n of 5. Easy breezy, okay? Now, the next 3 I'm going to show you are the important ones, all right? You need to write these down. You actually, probably what would benefit you would be to write it on a sticky note, and I'll show you my sticky note in a minute, but write these down, put them on a sticky note, and carry it around with you, okay? So, the summation formula as k goes from 1 to n of k is equal to n times n plus 1 over 2. This is the formula, okay? What I would suggest you do, though, is actually distribute this out and write it separate fractions. Meaning, what does this really look like? N times n plus 1 is really n squared plus n over 2. But I would even go further, and I would write it as n squared over 2 plus n over 2. Okay, write this down. You can write the whole thing down. You see my little sticky note right here. You can see it. I did write the whole thing down, but that's we're going to use the most. The next one is the sum of k squared as k goes from 1 to n, okay? And the formula is n times n plus 1 times 2n plus 1 over 6. Well, again, I would say let's FOIL this out. Let's factor this out, okay? So we'll just do this into this one. n squared plus n times 2n plus 1 over 6, which is going to be 2n cubed plus 3n plus n over 6. And then we're going to separate it into fractions. So it's going to be 2n cubed over 6, which reduces to n cubed over 3, plus 3n over 6, which reduces to n over 2, plus n over 6. So again, I would say write this and this one. All right, and then one more summation formula of k cubed. It's equal to n squared times n plus 1 squared over 4. Okay, so let's do this one. This, I'm just going to factor out that real quick. FOIL out that, excuse me. That would be n squared plus 2n plus 1. And then I'll FOIL in, that would be n to the 4th plus 2n cubed plus n squared over 4. And then I'm going to write each one as a separate fraction. So this would be n to the 4th over 4 plus 2n cubed over 4 reduces to n cubed over 2 plus n squared over 4. Okay? I'm going to show you tomorrow on examples how this is helpful. Okay? Bye.